everybody, this is section 11.4, and we're going to talk about volumes of prisms and cylinders in this section. Previously, we talked about surface area, and that is the amount of space outside the cylinder or the rectangular prism, or prism, any prism. Volume is the space that a figure occupies. So if I were to take a box, it's how much air it can hold, or how much, water it can hold. When we do volume, it's always going to be in cubic inches, feet, cubic units. One theorem for this section is capillaries principle, and that just says if two solids have the same height and the same cross-sectional area at every level, then they're going to have the same volume. It's almost like they're congruent, it's just they don't call it that. Right, to find the volume of a prism, you are going to do base times height. Now, the big B stands for the area of the base. So it's not just one number, it's the area of the base of the prism. So remember, prisms are named by the shape of the base. So you find the area of the base and then multiply it times the height to find the volume. All right, so here we want to find the volume of our rectangular prism. So volume again is going to be base times height. My base here is going to be right here. Again, we have to find the volume of that. So my base, if I'm finding the area of the base, it will be 20 times 24, and that is going to give me 480. And that would be centimeters squared right now because we're finding the area of the base. So then when I do the volume, I'm going to do my base, which is 480, times the height, which is 10 centimeters. And that is going to give me 4,800, and it will be centimeters cubed because it is volume. All right, next we are going to find the volume of a triangular prism. So we have to find the volume of the triangular prism. It means we have to find the area of each base. Here, remember our bases laying on its side are the triangles, and I know the bases are the triangles because they tell us it's a triangular prism. They did not give me the height of the triangle, because remember, to find the area of a triangle you need 1/2 base times height, and this little b stands for the base of the triangle. But they did tell me that this triangle is an equilateral triangle because I do know they mentioned all sides are 8 inches. So that means all angles are 60 degrees, and I need to find that height. When I drop my height or my altitude here, I form a special right triangle, a 30, 60, 90. So I know that this is 4 inches and this is 8 inches. So I could either do my Pythagorean theorem, or opposite the 30, remember, is x. Opposite the hypotenuse is 2x. And then opposite the 60-degree angle, it's always x times the square root of 3. So if I take 4 and multiply times the square root of 3, I get 4 square root 3. So that means to find the area of my base, I'm going to do 1/2. My base is 8 inches. My height is 4 square root 3. So I would do 1/2 8 times 4 square root 3. And that is going to give me, calculate that, approximately 27.7. And it would be inches squared because that's our base right now. Then our height is 10 inches, so I'm going to take this. That's my base of the triangular, so the area of the triangular prism, times my height. So when I do 27.7 times 10, I'm going to end up with 277 inches cubed. So the approximate volume, because I did round a little bit here, is 277 cubic inches. Next, we're going to look at the volume of a cylinder. And again, to find the volume of a cylinder, you're going to do base times height. But now, because our cylinder has a base of a circle, it would be pi times radius squared times height. So if I wanted to find the area of a cylinder, let's say I have a cylinder here. And I know the radius of the base is 3 centimeters. And the height, and we'll just make it 3 meters. And the height is 8 meters. To find the volume of the cylinder, I am going to do pi times radius squared, or 3 squared, times my height. So I would end up with pi times 9 times 8. Or if they wanted the exact answer, it would be 72 pi, and it would be meters cubed because it's volume. If they wanted approximate, I'm going to take the 72, I'm going to times it by 3.14. You could use the pi button. The approximate area would be 226 and 800 meters cubed. So the last thing we're going to look at is a composite solid. And a composite solid is a three-dimensional figure that is a combination of two or more simpler figures. So we take like a rectangle and a cylinder and put them together. You can figure out the volume by adding the two volumes for your figures together. All right, so here we have an aquarium, and they want us to find the volume of this composite figure. So it's not a rectangular aquarium. It appears to be rectangular, but then it has this cylinder up here on the front, or half of a cylinder. So to find the area of the aquarium, what I'm going to do is find the area of the cylinder, or half of the cylinder, and then also my rectangular solid, which is a prism. So let's start with looking at our cylinder, and this is the diameter of the cylinder. So that means if this is 24 inches, because it's rectangular here, this is going to be 24 inches. So that means my radius, if the diameter is 24, remember the radius is half the diameter, so the radius is 12. So what I'm going to do here is to find the volume of my cylinder, and it's only half of the cylinder, I am going to do 1/2 times base times height. And remember, base is the area of the top, so it's going to be pi times my radius squared, and then times my height. Now my height is right here, and it is also going to be 24, because if this is 24, then this right here would be 24. And when I calculate that, I'm going to do approximate, because they want to the nearest cubic inch, so they want approximate. So it is about 5,429 inches cubed, and that is just the cylinder. So this is the half cylinder. So that goes right there. Now we have to do the rectangular solid. So I need to do base times height. So my base, this whole thing is 48 inches, but I only need from here to here. Because I know the radius is 12, I know that this distance from here to here is 12. So if I do 48 minus 12, it's going to give me 36. So my base is 24 by 36. So for my volume here, I would do 24 times 36 times my height, which is again 24. And when I multiply that together, I end up with 20,736, and that is inches cubed. Now to find the total volume of the aquarium, you want to add these two together. So if I add 20,736 plus 5,429, the total volume of this composite figure is 26,165, and it would be inches cubed.